Good day everyone. We will discuss about the integration, the antiderivatives of algebraic function. We have discussed already the rules of differentiation, the chain rule, and the higher order of derivatives. Now we will talk about the anti-differentiation. So this is the inverse of differentiation, which is the anti-differentiation. The antiderivatives are indefinite integrals. So a function f is an antiderivative of the function f on an interval I if the f prime of x is equal to f of x for every value of x in that certain interval. Example, we'll get the antiderivative of 12x squared plus 2x. That's equivalent to 4x cubed plus x squared. So this is the antiderivative of our given function. Why? Because the derivative of the function, so the derivative of 4x cubed plus x squared is actually the function 12x squared plus 2x. Okay, so next is the antiderivative of g of x is equal to cosine x. It's actually the g of x is equal to sine x. Why? Because the derivative of the g prime of x is equal to the cosine x, which is also equal to the original function. So basically, it's the inverse of the derivative. So the antiderivative is the inverse of the process in getting the antiderivative of the function. Take note that the antiderivative of the function is not unique. Why? Example, we will get the antiderivative of the example that we have earlier, 12x squared plus 2x. So we have the answer. The original answer is f of x is equal to 4x cubed plus x squared. That's the antiderivative. But notice that the f of x is equal to 4x cubed plus x squared plus 1 is also the antiderivative of this one. Because 4x cubed plus x squared plus 1, if we will get the derivative, is equal to x squared plus 2x, which is equal to our function here. Another possible answer, the f of x is equal to 4x cubed plus x squared minus 1. Again, the derivative of, uh, of, of this one is this 12x squared plus 2x. So, it means that whatever you add or subtract, as long as it is a certain constant, that is equivalent to the antiderivative of that function. Okay, so another example here, the antiderivative of g of x, which is equal to cosine x, is first, g of x is equal to sine x, and it's possible that the answer is g of x is equal to sine x plus pi, because again, the derivative of sine x plus pi is cosine x. Okay, so antiderivative again, that's sine x minus 1, because the derivative of sine x minus 1 is equal to cosine x. So, if you add certain constant, you can derive the same answer for the corresponding derivative of the function. So again, our antiderivative of the function is not unique. So having said that, we will get the definition of the antiderivative. But first, we will take the terminologies and the notation of the antiderivative first. The antidifferentiation is the process of finding the antiderivative. The symbol is this one. This is the integral sign. It denotes the operation of the anti-differentiation. The function, or the f of x, is called the integrand. And if f is an antiderivative of the function, we write the integral of f of x dx is equal to f of x plus c, where c here is anything constant. But we always write c as our answer for the antiderivative. Take note that this symbol, the integral sign, and the dx, it always go hand in hand together. And dx, where x helps us identify the variable of the integration. And the expression f of x plus c is the general antiderivative of the function, while the antiderivative of f is called a particular antiderivative of f. So each antiderivative is a particular antiderivative, while if we put plus c, that's general antiderivative. So we always answer it in the general antiderivative, because again the answer is not unique, antiderivative is not unique, so we always put plus c to um, that is to emphasize that there are some values of a certain constant that is possible, that are also possible to get the real value or the derivative of the antiderivative of the function. Okay, so a recall. Let's recall the following differentiation formulas: that the derivative of x is actually 1, the derivative of x raised to n is nx to the n minus 1, where n is any real number, while the derivative of a times f of x, this is a constant rule, that's a times the derivative of f of x. And lastly, derivative of f of x plus minus the g of x is equal to the individual derivative. So derivative of f of x plus minus the derivative of g of x. So the remaining differentiation rules will have a different effect on the antiderivative rules. But for this one, it's very useful for antiderivative of a function. So here are the theorems on antidifferentiation. Okay, the integral dx is equal to x plus c. Okay, if n is any real number and n is not equal to -1, then integral of x to the n dx is equal to x raised to n plus 1 over n plus 1 plus c. Don't forget to write plus c every answer in antidifferentiation. So this is the inverse of the power rule in differentiation. Okay, so if a is a constant and f is a function, then the integral a of f of x dx is a the integral of f of x dx. Okay, so for constant rule, it's the same process here in antidifferentiation. You just separate the value of a constant and multiply that on that of the function. And lastly, if f and g are functions defined on the same interval, so the integral of f of x plus minus g of x dx is the integral of f of x dx plus minus the integral of g of x dx. So it means that we will get the individual derivative of a function of f of x and g of x for addition and subtraction. Okay, so we will start.